Alright guys, here's the warm-up for task number 1. This is a little bit of review from properties of logs for 1 and 2 and also evaluating logs. So you may want to stick them in exponential form. Same with number 3 in order to solve it. Number 4 is probably change a base formula. So hopefully you remember those. So go ahead and pause this video. When you come back, we will go over these together. All right, I hope that you really took the time to go over these warm-ups. It's important that you remember and try things on your own for your own learning. So just remember here, the plus sign, that means it's the product property, or I'm multiplying 8 times 4. So my first step for number 1 would be to write log base 2 of 32. And now I want to evaluate that. So I could put that into exponential form and say, I want to know what it equals, or what my exponent is, because remember, logs always equal exponents. I'll zoom in a little bit there. So I might write 2 to the x equals 32, and then know that 32 is 2 to the 5th power, so I want to make them the same base at that point, so that I know x equals 5, or that this whole expression equals 5. You might have been able to do it separately too, so there are 2 ways of doing this. For instance, if I wanted to know what exponent would give me 8 when I have base 2, this would be 3. What exponent would give me 4 from base 2, that would be 2, and 3 plus 2 is 5. So there's 2 different ways of doing that. All right, on number 2 we have division. So division between the 14 and the 2, so your first step could be log base 7 of 14 divided by 2, which is the same as log base 7 of 7. At this point, the properties of logs say that this would just be 1, but if you really couldn't figure it out, remember that whatever this equals, it equals the exponent. So 7 to the x equals 7. Well, we know this is really just to the first power, so that we could say log base 7 of 7 equals 1. And you could have seen that here as well, but not as easy doing it this way. So you can see, like this way, I could have had 2 ways of doing it, but here I really need to take the 14 and divide it by the 2, because there's no bases I can make the same with number 2. All right, number 3. When it says no calc, that's a hint that you can make the bases the same and that you should put it into exponential function. So we're going to have 216 to the x equals 36. And then the only thing that those have in common as far as bases would be base 6. So 6 cubed is 216, and that is all to the x, so that ends up being 6 to the 3x. And 36 is 6 squared. Once the bases are the same, those just cancel out, and I get 3x equals 2. And then solving for x, I get x equals 2/3. And then you could put it in your calculator, and if you put in the calculator with the change of base formula, you would see that you got 0.666 repeating. All right. There is no bases in common between 111 and 9, so that is when we need to use a calculator. So I'm going to have, using my change of base formula, log of 111 divided by log of my base, which is 9. These are both log base 10, so now I can just stick it in my calculator. Log 111 divided by log of 9. So then when I put that in, I get about 2.14. So this is approximately 2.14. All right. If you have any questions on that, maybe just pause your video. Here, I'll put it all together like this so you guys can see the work, so you could pause it. Make sure you get it down in your notes, or go through it until you understand it a little better. We are moving into solving basic logs today that I can't just put in exponential form right away. And so we can see this is log base 10 of 4x minus 3 equals 2. So I can't just evaluate this, but I could do the inverse on both sides. So when you had unlike bases with exponents, we did the inverse by taking the log of both sides. So the opposite of log is exponential. So I'm going to take the exponent of each side. And what I mean is, if this is log base 10, then I need to take the same base, which is 10, and take both sides 10 to the power of log 4x minus 3 and 10 squared, essentially. So really how this looks is 10 to the power of log of 4x minus 3 equals 10 squared. Now these undo each other. This power 10 and log base 10, they undo each other, giving me just 4x minus 3 equals 100, because 10 squared is 100. Then I would want to add 3 to both sides, giving me 4x equals 103. And then I would divide both sides by 4, give me x equals 103 over 4. It's probably a very ugly decimal, so 103 divided by 4, oh, it's not too bad, is 25.75. All right, so there's the full problem. On the next slide, you guys are going to get a chance to do 2 problems as practice problems. So maybe you want to pause and finish taking notes here. When I go to the next slide, I'm going to leave it up for a second before I start talking. So make sure you pause for a moment and then come back and finish it with me. All right. So here are your 2 practice problems. All right, so to undo log base 10, I need to take each side 10 to the power of. And then I can know that these undo each other, leaving me with 3 minus 2x equals 10 to the negative 1. 10 to the negative 1 is just 1/10 as a fraction. You guys might put 0.1, but I'm going to use 1/10. I'm going to subtract 3 from both sides, so leaving me with negative 2x equals 1/10 minus 3. Now if I want to have the same, or be able to subtract 3 from 1/10, I want to have a common denominator, so I multiply top and bottom by 10, which gives me negative 2x equals 1/10 minus 30 tenths. So this equals negative 2x equals negative 29 tenths. Sorry, that's kind of going off the screen there. And now if I divide both sides by negative 2, I'm going to get x equals a positive 29/20th. And I don't think that can be simplified. You may want to have used the decimals, but I got x equals 29/20th. So here's the full problem. If you want to pause and make sure you get that in your notes. All right, and then if we do problem B, same thing. It's base 10. So I'm going to take 10 to the power of on both sides. It's called exponentiating, but that's a big word. These undo each other, and I get 5x plus 2 equals 100. And then I subtract 2 from both sides. Obviously, they know we're in Algebra 2 trig, so they don't want to give us any nice answers at all. So I'm going to divide by 5 on both sides. I get x equals 98/5. Again, you're welcome to put that in decimal form, but I like to keep it in exact form with the fraction. You definitely want to get comfortable with fractions for pre-calc next year. All right, I'll see you with task 2.